Hello students, how are you all? I hope you are doing well and you are going through PGG World recorded videos which are uploaded in YouTube. Thank you so much for the another video. So which with your encouragement only, I'm trying to do complete series of solving previous year questions. Okay, so today our concept is a very interesting concept, that is moment of inertia. So there is a lot of confusion in the minds of students in solving numericals based on moment of inertia. I would like to give a complete clarity on this topic and the type of numericals comes based on this. Okay, okay. So let me start with a basic note, like what is moment of inertia, what kind of formulas we have for different rigid bodies, and what is the kinetic energy, translational kinetic energy, rotational kinetic energy of these rigid bodies. Let's get started. Moment of inertia. What's moment of inertia formula? Moment of inertia. What is the definition of it? First of all, try to understand definition. We did already came across the terminology called inertia. In the chapter laws of motion, we used to learn about this inertia. Okay, so the meaning of inertia is it's a property of a material, which tries to oppose its state of rest or motion, constant motion. It's a property of material which opposes its state of rest or uniform motion. That means object opposes its state of rest, or it doesn't want to, if it is at rest position, it doesn't want to change its state of rest. If it is already in constant motion, it doesn't want to come to rest position or doesn't want to change its velocity. So this is a general definition of inertia. So similarly, same type of definition we have for moment of inertia also. Moment of inertia is comes under rotation. So it's a property of a material, which opposes its state of rest or uniform rotation. It's a state of rest or uniform rotation. Hope you understood the difference between. So the object which is already moving with the constant velocity doesn't want to change its uniform motion. An object which is already moving with a uniform rotation doesn't want to change its uniform rotation, comes under moment of inertia. So here it is inertia. This is linear inertia and this is moment of inertia. Okay, so what are the types of formulas we have for moment of inertia? The very first one is moment of inertia of a point mass. Okay, look at this. Let's say a point mass m is rotating about an axis shown in the figure with an angular velocity omega at a distance r. So this is going to be the circular path of this particle of mass m. So just try to understand this. So this is how particle is revolving. Then moment of inertia of this particle is I is equal to m r square, where r is perpendicular distance of the particle from axis of rotation. So the axis around which the particle is rotating is called here axis of rotation. Hope you understood this complete line. This line is called as axis of rotation. Moment of inertia formula is m r square. This is applicable for a point mass. So applicable for point mass. If any point mass is revolving around an axis at a distance r, particle mass is m, the moment of inertia is I is equal to m r square and applicable for point mass. Remember this. So what's r is here? R is perpendicular distance of the particle, from axis of rotation, Hope you understood. So this is applicable for point mass. Remember. Next, first of all, let's understand the meaning of its axis or own axis. The meaning of its axis or own axis is axis passing through center of mass, and perpendicular to the plane of the body. Passing through center of mass and perpendicular to the plane of the body. Passing through center of mass is nothing but passing through its axis. Understood? For different types of rigid bodies, we have different types of moment of inertia. Let's look at these different objects. The moment of inertia of the ring whose mass is capital M and radius is r. For all these objects, I'm going to find out moment of inertia through the axis which is passing through center of mass and perpendicular to plane of those objects. So whatever the axis I did represented here, that axis is called as its axis for these objects. Okay. For ring, moment of inertia I is equal to m r square. For disk, it is going to be m r square by 2. So you just have to remember this formulas. Okay, well? It is I is equal to m r square by 2 for disk. When it comes to hollow cylinder, moment of inertia for ring and moment of inertia for hollow cylinder is both are same. That is I is equal to m r square only, because hollow cylinder is a combination of n numbers of rings. So when it comes to solid cylinder moment of inertia is the same as disk moment of inertia, because solid cylinder is a combination of n number of disks. I is equal to m r square by 2. Very good. Next, moment of inertia of a hollow sphere of mass capital M and radius is capital R. So it is 2 by 3 m r square. 2 by 3 m r square. Moment of inertia of a solid sphere is I is equal to 2 by 5 m r square. This is moment of inertia for solid sphere. And moment of inertia of a linear rod whose axis is passing through center of mass and perpendicular to the axis of the rod. Here it is. So what is the axis of the rod? This is how axis of the rod is represented. Okay, so this axis which is passing through center of mass is perpendicular to the axis of the rod. This is axis of rod, and formula for moment of inertia is I is equal to m l square by 12, where m is mass, l is length of that radius. Got it? Is it clear, ma? Understood? So just remember these formulas of different types of moment of inertia. Based on this only we are going to get the questions. Okay? And one more thing I would like to mention is energy of translational rotational body and rotational body. We are going to get 3 different types of energies on the object. Let me give you the difference of translational energy, rotational energy, and rolling object, what kind of energy it is we having. Slipping, in the sense object is having only translational motion. That means each and every particle of this rigid body moves in only one direction, like this. This is how it is going to be. Let me consider center of mass and these objects. Center of mass is having, let's say, velocity v. The particle at this point is also having velocity v. So each and every particle at any position will be having a same velocity, and that is equal to v. In rotational or spinning motion, this is also called as a pure rotation. Okay, so in this pure rotation, object doesn't displace, it will rotate on at the same position itself. That means velocity of center of mass is equal to 0. The particle which is at the topmost point will move forward with a velocity v. The particle which is at the bottom will move backward with the same velocity v. Particle at this position will move upward with a velocity v. Particle at this position will move downward with a velocity v. This is called as pure rotational motion or spinning. Okay, hope you understood the difference between slipping and spinning. Slipping in the sense object is just displaces from one position to another position without rotation. In slipping, each and every particle will be having same velocity. But when it comes to pure rotational or spinning, object's velocity of center of mass is going to be 0. Simple example is sugarcane wheel. So we used to have sugarcane juice during summer, right? At that moment, if you observe that wheel of that sugarcane machine, wheel is just rotating on that spot itself. It is not displacing. That can be treated as an example for rotational motion. When it comes to rolling motion, it's a combination of translational plus rotational. It's a combination of translational plus rotational. That means objects at the top, you just add the velocities. So position 1, if you observe position 1, both the cases objects are moving in the same direction. So if you add those velocities are going to be 2. So this one, velocity at position 1, velocity at this position 1. If both are in same direction, if you add them, it is going to be 0. Velocity at the bottom is equal to 0 because velocity at position 2. So one is towards right, another one is towards left. So velocity at the bottom is going to be 0. Now let me consider velocity at this position. So you are going to get due to translational motion, it is going to be towards right. Due to rotational, it is going to be down like this. Then magnitude of this is v and this is also v. We are going to get magnitude as v root 2. Similarly, velocity at this point. So one is towards right, which is v. Another one is up. One is due to rotational. Another one is translational. Resultant is going to be v root 2. So this is the way to represent different types of velocities acting on those particles. So how did I wrote v root 2? So these two are at an angle 90 degrees and those magnitudes of velocities are same. So resultant is going to be v root 2. By using Pythagoras rule, we can find it. So types of energies. In this case, we are going to get, first case we are going to get only translational kinetic energy, and it is represented as KET, which is equal to 1/2 mv square. Next, rotational kinetic energy, it is represented as 1/2 I omega square. So I is nothing but moment of inertia of different types of object. Here it is total kinetic energy is equal to translational kinetic energy plus rotational kinetic energy. So this is the total kinetic energy of the object if it is rolling in the sense it is rotating by its own, at the same time it is displacing from one position to another position. This is how we have to represent different types of energies of the object in their respective motions like translational, rotational and rolling motion. Hope you understood, guys. One more important thing that we have to learn about moment of inertia is theorems. We have two different types of theorems. Those are perpendicular axis theorem and parallel axis theorem. Look at this. I have given certain rules for applying this perpendicular axis theorem and parallel axis theorem. Let me read it out one by one and try to understand each and every point which was written over there. Okay, let me start from point to point. The very first point for rules. Okay, so all the three axes must be perpendicular with each other. Okay, that means we have to take a coordinate axis x, y, z. Here it is, I've shown x, y, z axis system. Okay, okay, all these three axes are perpendicular with each other, right? Yes, it is. One more point, two axes must be perpendicular to each other and lying on the plane of the body. Observe x axis and y axis, those two are perpendicular with each other. Yes, they are following that condition, 90 degrees with each other. And one more point they are following is they are on the plane of the body. So this is the object, this is a rigid body, these two axes are present on the plane of that body. Yes, second condition is also satisfied. Okay, now what's the third condition? Third condition is remaining or third axis is perpendicular to plane containing those two axes. Observe z axis. Z axis is perpendicular to both x axis at the same time y axis. So if you observe here, this is how it is represented. Z axis is perpendicular to both x axis and y axis, and it is perpendicular to plane of the body which contains x and y axis. Then moment of inertia about z axis is equal to ix plus iy. Understood, ma? Next, parallel axis theorem. There are certain rules to be followed to apply parallel axis theorem. Look at this. The very first point, two axes must be parallel with each other. Okay, observe these axes, I and I center of mass. These axes are parallel with each other. And one more thing, one axis must pass through center of mass of the object. This is crucial point, very important. One of the axis must and should pass through center of mass. Look at this. Next, so how to find out center of mass about this axis? Then I is equal to I center of mass plus ma square. What about A? What's the meaning of A? Here A is defined as perpendicular distance between those two axes. A is perpendicular distance between the axes, parallel axis. We can write on the points. Okay, so it is perpendicular distance between parallel axis. Is it clear, ma? And one more last and final point that we have to remember is radius of gyration formula. Okay, what? Radius of gyration. Look at this definition. Radius of gyration, it is actually represented with k. It is perpendicular distance of a point from the axis where whole mass of the body were concentrated. Let me consider a rigid body, and this is axis of rotation. It is represented like this. So let me consider at some position total mass of the system is looking like it is acting at that point, and distance of from this axis to that point where total mass is present looks like it is present is k. Then moment of inertia is mk square, and k is equal to root of I by m is the radius of gyration formula. Very, very important. These are the important points that we need to understand when we are about to solve numericals based on moment of inertia. So try to go through these points again and again and again, then try to solve the numericals. Let me solve numericals one by one, and let's see what different kinds of numericals we can see from these kind of concepts. Let's solve the numericals based on the concepts whatever we discussed till now. Okay, so look at the very first question. A solid sphere of mass m and radius R is rotating about its diameter. Super. Solid sphere. Let me represent that. So 34 solution. First one they're asking is solid sphere. It is rotating about its diameter. This is the meaning of rotating about its diameter. Okay, so what is the moment of inertia of this solid sphere rotating about its diameter? It is going to be 2 by 5 mr square. Already given these formulas, so you just can go through the formulas here. Here it is. Next, A solid cylinder of the same mass and same radius is also rotating about its geometrical axis with an angular speed twice that of the sphere. Very good. So another one is solid cylinder. Okay, let me represent that. Solid cylinder. Both of them are solid objects. So another one is a solid cylinder is rotating about its geometrical axis. Its geometrical axis is nothing but about its axis. I've already told you the meaning of about its axis. This is how it is rotating. But so angular speed of a solid cylinder is 2 times of angular speed of solid sphere. So that is what they have given. They're asking the ratio of their kinetic energies of rotation. Super. So radius of these two objects is going to be same. Mass m and radius is same. Mass is also same. What is the rotational kinetic energy formula of these two objects? That is kinetic energy of the sphere, which is equal to 1 by 2 I omega square, right? So what about kinetic energy of the cylinder also? Cylinder is equal to 1 by 2 I omega square. So in this case, what's the moment of inertia of this body? 1 by 2 by 5 m r square omega square. Very good. So this one can be written as 2 will get cancelled out. You are going to get m r square omega square by 5. Okay, look at this. Kinetic energy of the cylinder which is equal to 1 by 2. Moment of inertia of the solid cylinder is m r square by 2. It is the same as disk omega square. So kinetic energy of the cylinder is equal to it is going to be m r square omega square by 4. What is the question they're asking? They're asking ratio, right? One more small point that we have to represent is, here it is, the angular speed of this solid cylinder is 2 times of angular speed of sphere. So that is the point we forgot to mention here. It is going to be square. So you are going to get, in addition, 4 will get cancelled. I need ratio. So kinetic energy of a sphere divided by kinetic energy of cylinder, which is equal to m r square omega square by 5 divided by m r square omega square. It will get cancelled. So finally we are going to get the ratio 1:5. Which option is correct? Option B is correct. Very good. Let me solve the next question. Hope you understood, guys. Next, a light rod of length L has two masses m1 and m2 attached to its two ends. Okay. Question number 35. This is how the diagram is represented here. So length of this rod is going to be L. This one already they have given in the question. Okay, so what is the final question they are asking? They are asking the moment of inertia of the system about an axis perpendicular to the rod and passing through the center of mass. Do we know center of mass location? Is it exactly at the center? No, it is not. We don't know center of mass location. Let me represent somewhere else. This is center of mass location I have to find out. So we know the procedure how to find out center of mass. I have already given a trick that if you are finding center of mass from M1, you have to select opposite mass and you can find out center mass very easily, right? So this is a center of mass location. First of all, let me find out center of mass. So center of mass is equal to, so from M1 it is going to be, M1 is the reference I am going to take. So X center of mass. So it is going to be M2 into distance of separation, M2 into L divided by M1 plus M2. So this is center of mass from M1. From M1. Okay, well, so let me treat this is as R. Okay, well, so this is going to be R. So how to find out remaining distance? It is going to be L minus R. So what about L minus R, which is equal to L minus R is M2L divided by M1 plus M2. So L minus R, which is equal to M1L plus M2L minus M2L divided by M1 plus M2. So this one already I've given a hint. So L minus R is equal to M1L by M1 plus M2. So we just go through the first video of system of particles numericals. In that case, I've already given a hint. So distance of center of mass from M1 is opposite mass M2 into total distance of separation divided by sum of the masses. So distance of the center of mass from M2 is opposite mass, that is M1 into total distance of separation L divided by sum of the masses. Now I need moment of inertia about this center of mass, that is I is equal to M1 R square plus M2 into L minus R whole square. So mass M into R square is the formula, right? Let me represent that. M1 R square is nothing but M2 square L square divided by M1 plus M2 whole square plus M2 into L minus R is M1 square L square divided by M1 plus M2 whole square. So this is the way to represent. So in this, let me represent options. Options are given in a different format. Here L square by M1 plus M2 is whole square is a common, right? Let me remove that. L square by M1 plus M2 whole square into M1 M2 square plus M2 M1 square. Again M1 M2 can be removed. So L square divided by M1 plus M2 whole square. From this we can come on M1 M2 into, this is going to be M2 plus M1. M2 plus M1, M2 plus M1 will get cancelled out. What is the answer I'm left with? It is going to be M1 M2 L square divided by M1 plus M2. So which option matches? In this case, it is going to be first option. So M1 M2 by M1 plus M2 into L square. Is it clear, guys? Yes, it is. Now observe question number 36. From a circular disc of radius capital R and mass 9m, a small disc of mass capital M and radius R by 3 is removed. Okay, super. Now from this disc, a small disc of radius R by 3 and mass capital M is removed. Okay, super. Removed concentrically. This is the meaning of concentrically. So the meaning of concentrically is their center of masses should be at the same position. Okay, the moment of inertia of the remaining disk about an axis perpendicular to plane of the disk and passing through center of mass. This is nothing but its axis. So this is the meaning of this is its axis. We already told you the meaning of its axis. Axis is passing through center of mass and perpendicular to the plane. Let me find out moment of inertia before removing the small disk. So that is equal to disk moment of inertia is mr square by 2. As mass is 9m, let me represent it as 9mr square divided by 2. This is the moment of inertia of the original body. Now let me find out moment of inertia of the removed portion, that is a small portion. That is mass of that body is m, radius is r by 3 whole square divided by 2, mr square by 2. I'm just following that formula. Here radius is r by 3. Now I need moment of inertia of the remaining portion, in the sense moment of inertia of the original body minus moment of inertia of the removed portion will give you exact answer. It is going to be 9mr square divided by 2 minus mr square divided by 18. So mr square by 9 goes to denominator, it will become 18. So try to equate the denominator. So numerator, try to multiply it with 9, divide it with 9, so that it is possible for me to equate the denominator. It is going to be 9 nines is 81. 81 mr square minus mr square divided by 18, which is equal to 80 mr square divided by 18. So this one again can be converted as 40 mr square by 9. So this is the answer for this given question. So which option matches? Option A is correct. Very good. Understood, ma? Is it clear? Next, question number 37. So in question number 37, let's see what is the thing they're asking. The ratio of radius of gyration of a circular disc to that of circular ring. Super. Each of same mass and radius around their respective axis. The meaning of respective axis is also its axis. We already know the meaning of its axis. What is the meaning of its axis? Axis passing through center of mass and perpendicular to plane containing the body. They are asking radius of gyration. We already discussed about the formula for radius of gyration. Radius of gyration can be written as I is equal to m k square. I is equal to m k square, whereas k is equal to root of I by m. So I is moment of inertia, m is mass of that particular body. So they are asking radius of gyration for a circular disc and the circular ring. So radius of gyration for circular disc, let me write down for a disc divided by radius of gyration for a ring is equal to, so this is for ring, which is equal to root of moment of inertia of the disc is going to be mr square by 2 divided by, again divided by mass will be there. So okay, so instead of that we can write down it is as 2m, right? We can replace it as 2m. Next, moment of inertia of the ring, it is going to be mr square divided by m will be there. So m will get cancelled, m will get cancelled, r square will get cancelled. We are going to left with 1 by root 2. So which option matches? Option D is the correct answer. Is it clear, guys? Very good. Now observe the next question. Sorry, question number 37, option D is correct. Oh, both are looking like same one. Okay, next question, 38 solution. In 38, two bodies have their moments of inertia I and 2I respectively about their axis of rotation. Okay, if their kinetic energies of rotation are equal, then their angular velocities will be super. They said kinetic energies of those two objects is equal. Two bodies are having moment of inertia I and 2I. Okay, they said kinetic energies are equal. Kinetic energy of first particle is equal to kinetic energy of second particle. Kinetic energy formula in terms of moment of inertia and angular velocity is 1 by 2 I1 omega 1 square is equal to 1 by 2 I2 omega 2 square. I2 1 by 2 1 by 2 will get cancelled. I1 is I omega 1 square, which is equal to I2 is 2 times of I omega 2 square. They are asking the ratio of their kinetic energy, right? No, they are asking their angular velocity ratio, that is W1 by W2 whole square or W2 by W1 whole square. It is W1 by W2. That means they are asking respective words. Whole square is equal to I will get cancelled. We are going to get 2. Then W1 by W2 is the angular velocity ratio, which is equal to root 2 by 1. Root 2 is to 1 is the answer. Which option matches? Option C is the correct answer. Okay, next question looking like somewhat interesting. Try to answer that question by pausing the video. Then it is going to be very easy for you to understand and then to apply. So don't just see the solution, you just try by your own, then you will learn it. Three particles each of mass m gram are situated at the vertices of an equilateral triangle ABC of side L centimeter. Okay, this is how diagram is represented. They're asking moment of inertia of the system about a line perpendicular to AB. This line is X. So A to X line, which is perpendicular to AB and in the plane of ABC. This axis is in the plane of ABC. If they said it is perpendicular, either it is out of the board or into the board. That is the meaning over there. Let me find out moment of inertia of this. So I've divided instead of dividing. So if you observe mass at position A, it is on the origin itself. Let me treat it as at a position 0, 0. Perpendicular distance of mass at position A is going to be 0 only. What is perpendicular distance of mass at position B? It is going to be L. Okay, super. Let's say coordinates of them is going to be L, 0. Do I know coordinates of this particle? This is what I have to find out, and it is going to be L by 2, right? I need distance of separation from the axis of rotation. So from the axis of rotation, I did represented different positions of those particles. Then moment of inertia is equal to moment of inertia of particle at position A, position B and position C. So moment of inertia of the particle which is at position A is going to be 0 because it is on the origin itself. Next, moment of inertia of particle B is m L square plus next m L square by 4. So final answer it is going to be 5 m L square by 4. This is the answer. Which option matches? Option C is correct option for 39. Is it clear? Super. Next, question number 40. A circular disc is to be made by using iron and aluminum. Super. Question number 40, solution. Try to understand. I need a circular disc. Super. With the help of two different types of material. One is iron, another one is aluminum. Generally, whose mass per unit volume is more? Aluminium. What's answer? Whose mass per unit volume? In the sense, whose density is greater? Generally, density of iron is greater than density of aluminum. That means mass per unit volume of the iron is greater than mass per unit volume of density. Then, what is the question they are asking? They are asking so that it acquires maximum moment of inertia about geometrical axis. Okay, so about geometrical axis in the sense axis passing through center of mass and perpendicular to the plane. Now I have to select two rings, whether it is going to be interior or outerior. That is what I have to check out. Let's say this is radius R1 and this is going to be R2. So which is first ring, which is a second ring? That is what I have to decide. Okay, well, it's a combination of different types of rings. Now observe, to get maximum moment of inertia. Generally, what's the moment of inertia formula? I is equal to m r square by 2 for the disk, right? This is the moment of inertia. Can I say I is directly proportional to m, at the same time directly proportional to r square, right? So to get maximum moment of inertia, mass and radius should be greater. That means object which is already having greater mass is iron and the radius should be greater. That means iron piece should be outside, aluminum should be inside. So which option matches? Aluminum at interior and iron is surrounding. Hope you understood. If iron is outside, then radius is going to be more, then moment of inertia is going to be automatically a greater value. Okay, super. Now observe question number 41. So for the adjoining diagram, the correct relation between I1, I2, and I3 is moment of inertia. So question number 41. So there is a formula for moment of inertia of a triangular lamina. So I didn't give that at the time of giving note. So look at this. If triangular lamina is rotating about this base, let's say height is going to be h and mass of this triangular laminae is I, so omega, so moment of inertia is going to be mh square by 6. So this is the formula for moment of inertia of a triangular lamina. So here I is directly proportional to h square, right? So h is the perpendicular distance of this triangular lamina from its base. Now look at the question number 41 and 42. So both are same questions. Let me explain you both of them. Here it is. So 41 question they have represented like this. It is I1, I2 and I3. So I1 side is 4, I2 side is 5, I3 side is 3. So one thing you have to remember is if h is greater, definitely I is going to be also greater. Now if I take base as I3, then what about height? Height is going to be 4. Okay. If I take I1 as base, then h is going to be 3. In which case height is greater? Definitely I3 case, right? If I take I3 as base, that means B to C as a reference, that's the axis of rotation, then height is going to be 4. If I take A and B as a reference, height is going to be 3. Try to understand, ma? So this is the rule I am going to follow. If I take, let me write down this. If I take BC as a reference, moment of inertia is going to be m4 square by 6, right? So this is the reference. Moment of inertia about this point IBC is equal to m h square. H square is 4 square by 6. Next, if I take a reference as AB, if I take this reference, so this is going to be the reference. If I take this is as a reference, then what is going to be moment of inertia? Moment of inertia is going to be, okay, so this is how it is. Moment of inertia is, this is IBC and this is going to be IAB. This is IBC. Moment of inertia is IAB, which is equal to m3 square divided by 6. So comparing to these two, which is whose moment of inertia is greater? Definitely IBC is greater than IAB. Remember that. Definite. One more point you have to remember. So distance from this axis, which is here it is. This is how moment of inertia is. This is I2, right? Very good. So moment of inertia with respect to I2 is, we have to find out this distance, and it is definitely less than 4 and less than 3. Remember that. So the distance, then I2 is nothing but A to C. So that is A to C is definitely less than these two moment of inertia. So that is the reason I didn't consider. Which option is correct for 41? IBC is I3, IAB is I1. That means I3 is greater than I1. So option C is correct. Very good. Now look at the question number 42. So this is answer for 41. Look at the question number 42. 42 is also of similar model. Now observe question number 42. The ABC is a triangular plate of uniform thickness. The sides are in the ratio as shown in the figure. Okay, IAB, IBC and ICE are the moments of inertia of the plate about AB, BC and CA respectively. Which of the following relations is correct? Just now I told you. So which is greater? Definitely here it is. IBC is greater than IAB, which is greater than IAC. Which option matches? IBC is greater than IAB. So option D is the correct answer. Okay, ma? Is it clear? Understood? Let me read out the question. What is the thing they have given? In a rectangle ABCD, BC is equal to 2 times of AB. Okay, let me assume A to B distance is, let's say it is L. Then what is going to be B to C distance? It is going to be 2 times of L. They did mention in the question itself. B2C is equal to 2 times of AB. Okay, then what's the question they're asking? The moment of inertia is minimum along the axis. Super. How to answer these kind of questions when they give in competitive examination in a very less time? Okay, so let me explain you the trick here. So only thing you have to observe. So what's the moment of inertia formula, ma? So moment of inertia formula is generally it is mr square for a point mass, right? So is moment of inertia depends on mass of these objects? Just think about it whether it is going to be s or no. As it is here, it is directly proportional to m, right? And it is proportional to radius of the body also. Okay, so while you are finding moment of inertia, one thing you have to observe carefully is mass distribution should be very less and distance should be very lesser, so from the axis of rotation. So let me try one by one and let's solve whether it is going to be correct or not. Okay, so this mr square is for applicable for point mass only. This one I given only for just for understanding. Okay, it is applicable only for point mass. Now let me observe moment of inertia. They are given some options, right? Moment of inertia along BC. So if I take moment of inertia along BC, so total mass is at a distance of L. So I'm just writing it is as proportional to L square. Okay, so what about moment of inertia about BD? If you want to find out moment of inertia about BD, so this is how it is. So its mass distribution is at a very small distance from its axis? No, it is not. So observe the axis at a different location. Now if I observe here the moment of inertia of the axis which is passing through E and G, so that is going to give you the least distance. So this is how it is going to be L by 2 distance. This is going to provide L by 2 distance. Remaining all of them mass distribution from the axis of rotation is at a large distance, but this is the only axis through which mass distribution is at a small distance. So that's why moment of inertia about the axis EG is small. Moment of inertia about the axis EG is small. So which option is matching? Option D is the correct answer. Is it clear, guys? Yes, it is. Super. Next, a flywheel rotating about fixed axis has a kinetic energy of 360 joules. Look at this. A flywheel rotating about fixed axis has a kinetic energy of 360 joule. So wheel rotating in the sense what kind of energy it will be having? It will be having rotational kinetic energy. Question number 44 solution. What's the rotational kinetic energy formula, which is equal to 1 by 2 I omega square? Okay, so everything is okay. What's the question they're asking? So when its angular speed is 30 radian per second, the moment of inertia of the wheel they are asking. Super. So kinetic energy they have already given, it is going to be 360 joules. 1 by 2 into moment of inertia value. So we don't know, that's what we have to find out. Moment of inertia is I. Omega value they are given in terms of radian per second. Okay, let me substitute that. It is going to be 30 squared. So finally I is equal to 2 into 360 divided by 900. So it is going to be 4 the 40 and it is going to be 100. 0 0 will get cancelled. 2 4 the 8. 8 by 10 it is going to be 0.8. So which option matches? It is kg meter square. Which option matches correctly? For 44, option C is the correct answer. Is it clear, guys? Yes, it is. Next question number 45. Let me solve that. Question number 45. What is the question? They said a ring of mass capital M and small m and radius r rotate about an axis passing through its center and perpendicular to its plane with an angular velocity omega. So the kinetic energy is, So they are given mass and radius, right? So moment of inertia is going to be what's the kind? First of all, tell me what is the kinetic energy of that particle? Kinetic energy of a rotating body is equal to 1 by 2 I omega square. Right? A ring of mass m and radius r rotates about an axis. In the sense, you have to consider only rotational kinetic energy, that is 1 by 2 I omega square. From this, what's the value we have to find out? This is the value only. Moment of inertia of that ring is equal to 1 by 2 m r square omega square. Which option matches perfectly? 1 by 2 m r square omega square. 1 by 2 m r square omega. So option A is the correct answer. Very good. Next question number 46. From this concept we are going to solve numericals based on theorems of perpendicular and parallel axis. I did already given instructions so how to apply parallel and perpendicular axis. So this is how numericals came in previous years in NEET examination. In the next video we are going to see the applications of perpendicular and parallel axis theorems. Okay, very good. Have a nice day, guys. So hope you are enjoying the series. Bye.